Okay, so welcome to Trigonometry Exam 2 Review. Just remember that this is being recorded, and if you go out to the online math resource, everything that we're doing during this will be uploaded into the test review material. You can see our previous exam 1 here with both a version I recorded in the springtime and a version I recorded this summer. So you have 2 exams there, and you're now going to have 2 exams for this. Okay, so the first piece is a blank review. The next one is the solutions, which we're working up right now. The third one is where this video is going. All right, so let's do this. So we've got our exam right here. I'm going to go ahead and just close down my internet so that way we don't have to worry about that. And in here, a lot of this, you're going to see some verifying and things like that. Just know that when we verify, we're looking for simple things. Some of these are not like the crazy examples you had in the homework. Okay, these are going to be straightforward examples, so don't worry too much about the verifying from that section 10.1 and occasionally in 10.2, 10.3, and 10.4 at the end. If we do verifying, we want to keep it very, very simple. Okay, where when you verify, it's either going to come out as a constant, which is a single number, or a single trig function like sine, cosine, okay, tangent, or a power of a trig function like sine squared, tangent squared, cosecant squared, things like that. Okay, they're going to come out nice and simple for us. And sometimes you'll even have that multiple choice answer right down there to see which one it is. Okay, so when we look at number 1, we want to take cotangent x and sine x being multiplied together, and we want to simplify, or in other words, we want to try and reduce it as far as we can to either a number, a single trig function, or a power trig function. Okay, so with that being said, one of the things with verifying is that when I teach my classes, I tell my students the rules of the game. Okay, because verifying is like playing a game. It's like a puzzle, and you're trying to get from one end to the other. Sometimes you don't know what the end picture is supposed to look like, but again, our directions tell us what they want: a constant, a single trig function, or a power function. So these tools that I give them, or I call them the rules of the game, are like change everything to sines and cosines, apply a trig identity, factor, try factoring, multiply both sides by 1, work on the harder side and get it to the easier side if you know both sides. Things like that. Because I can tell you there's no process to get through this. There's no one way to do this. There are lots of ways, and that's all about what you see and can remember. Okay? So in here, one of the tricks that I implore you to use is change everything to sines and cosines. It's a pretty common trick, and it's probably the most useful when it comes to this exam. And also don't forget about identities like the Pythagorean identities: sine squared plus cosine squared equals 1. Don't forget about those because you can use those here. Okay, so those are the 2 big ones that you really need to use for the exam. So let's change cotangent into sines and cosines. Well, cotangent in sines and cosines is cosine x over sine x. And we're multiplying that by sine x. So it is changing it into sines and cosines, but this is also an identity because we know that cotangent is really cosine x over sine x. All I did was take out the cotangent and put another identity in for it, which is changing it to sines and cosines. And what's going to happen between these 2 pieces? Well, the sines are actually going to cancel out because if you remember, when you're multiplying rationals, and a lot of verifying is also using algebra tricks, sine is actually over the number 1. And if you remember, whenever you have a number in the numerator that matches a number in the denominator, They just cancel each other out. Okay, trig functions act the same way as numbers because that's all a trig function is. It really is a number in disguise, like pi. Okay, so sine cancels sine, which leaves you with cosine x. And that's what they want. That is a single trig function. There's no other reducing there that you can do. Okay, so again, this is coming from 10.1. Number 2, continuing on. So number 2, we've got this cosine beta, tangent beta, all over sine beta. Okay? So in this one, again, you can convert things to sines and cosines. You can use identities to try and help you out. There's nothing wrong with that. So again, my advice to you is I would use identities. Okay? Use those identities to help you out. And so I would change things again into sines and cosines. So take the tangent and use an identity and change it into sines and cosines. Okay? Well, if cotangent is cosine over sine, then that means we know that tangent beta has to equal sine beta over cosine beta. And so what we have is this. You got sine beta on the bottom, and up top you've got cosine beta times sine beta over cosine beta. So what's going to happen right here is a lot like what just happened right up here. It's just the reverse of this. This time you have cosine that's multiplying this fraction, and the cosines are going to cancel out. It's the same situation that we just had right here, but with cosines being in these spots. And so that's going to leave you in the numerator with sine beta over sine beta. And when you take sine divided by sine, that's 1. And there you go. So when we go back to this, we're looking for an actual multiple choice answer. So the answer is B. Okay. Also, a couple things that you can do in here. Right away, you can get rid of C because C says we need, or the directions say we want a single trig function or a power of a trig function. And C does not have a single trig function. So right away, you know it's one of these 3 answers. Easy peasy. All right, the next one. So still in 10.1. All these are 10.1. We've got secant squared x minus tangent squared x. So again, they want a single trig function or a power of a trig function. So all these answers are definitely in play, just so you know, because they either have a single trig function or actually it's a number. So there's nothing wrong with that. Nothing wrong with having a constant for your answer either. So we go back over here. Here's our problem. Okay. So how can we deal with this? Well, you need to remember that you have a Pythagorean identity. There's a Pythagorean identity that says tangent squared x plus 1 equals secant squared, forgot my C, secant squared x. Gotta do a quick fix. So secant squared x. Well, if you do a little manipulation and we get the secant and the tangent on the same side, like up here, we're going to subtract tangent squared x to the other side. And if you look at this, you've got 1 equal to secant squared x minus tangent squared. Yeah, there are Pythagorean identities that we know, and remember that they can be manipulated in lots of ways. Okay, so if you look right here, secant squared minus tangent squared matches this. It's in that same order. So what does this equal? 1. And when we go back, the answer would be C. Okay. Number 4. Moving on. So we got 1 minus sine squared theta. Again, right here, use the same idea that we just did in number 3. We have a trig identity that we know about. In fact, I said it earlier in this video, that sine squared theta plus cosine squared theta is equal to 1. Move the sine over to the 1 side because we want a relationship with 1 and sine. So sine squared theta, we're subtracting sine squared theta. So we know that cosine squared theta is equal to 1 minus sine squared theta. Notice again, this matches, so we can replace this with the identity of cosine squared theta, which when we go back and we look, you actually have to fill in the blank. Okay, so a couple things right here. It says write the following expression in terms of sine and cosine and simplify. What they're meaning right here, the final expression does not necessarily have to be in terms of sine and cosine. Meaning that it could be a number. So like it could have been the number 1. Okay, so a constant is what they're meaning there. All right, number 5. So again, we're still in 10.1. So we have negative sine squared theta and negative 1 minus cotangent squared theta. Okay? And again, they want us to simplify, and they want it in terms of sines and cosines. Okay? And they do not want any quotients. Quotients means no division. All right? So right away, we know that we don't want any of this stuff right here. Okay? We don't want that because that's showing us division. All right? So it's either got to be any of these that are up here. So let's take and dive deeper into this problem. So the first thing I would do is I would turn these into sines and cosines. Because I already got sine right here, why not change this into its sine and cosines? And we've already talked about earlier what that looks like. So you know that cotangent theta is equal to cosine theta over sine theta. So we're going to have negative sine squared theta, parenthesis, negative 1, minus, and because this is squared, that will also make these squared as well. So minus cosine squared theta all over sine squared theta. Okay? So now what you want to do is you want to just do a little bit of math. Let's distribute through. Okay, a little bit of algebra. So we're going to distribute through this thing. And a negative times a negative is a positive. So this will give us a positive sine squared theta. A negative times a negative is a positive, so that's a plus. And the sine squareds are actually going to cancel out because this is in the numerator, this is in the denominator. So that's going to leave us with cosine squared theta. But wait a minute, there's more. We've seen this. In fact, we talked about this one in problem number 4, right before this. And we stated that sine squared theta plus cosine squared theta is equal to 1. These two pieces match. So the answer is 1 because I can replace it with the identity. So when I come back here, the answer is A. See, 5 problems, and all we have done is to use the Pythagorean, the Pythagorean identities, and use a little bit of changing sines and cosines. Nothing crazy. Not like what you had to deal with in your assignments. Okay? All right. So again, simplify so that there's no quotients, which means no division. And so we just want to take it so that everything is top heavy like these. So all of these are possible because it doesn't say that we have to be in sines and cosines. Okay? So cosine theta minus tan theta all over tan theta cosine theta. Let's simplify this thing down. So here's what's really cool. Whenever you have like a solid denominator right here, and there's addition and subtraction going on in the numerator, you can separate these out into the two fractions they are, because this is really two fractions that got subtracted together. Okay? So that's one of the tricks you can use, you know? We can separate it out into two fractions because of the addition and subtraction that's in the numerator. And you can also reverse it. Know that if you have two fractions with a common denominator, you can put them back together. Okay, but we want to separate these because that's going to make things easier for us. Okay, so we're going to have cosine theta over tangent theta cosine theta minus tangent theta over tangent theta cosine theta. So we separated them out. Okay. Well, hopefully, as you notice, as we're separating, we've got things that are in common in the numerator and denominator. They're going to cancel each other out. Cosine goes away, leaving you with 1 over tangent theta. Minus the tangents go away, leaving you with 1 over cosine theta. Now, again, we don't want the division, but you have seen these relationships before. This is just meaning what is the reciprocal of tangent? What is the reciprocal of cosine? So remember, the reciprocal of tangent is cotangent, because you've seen that relationship before. Cotangent is just the reciprocal of tangent. And the reciprocal of cosine is secant. Okay, so all we're going to do is just replace these, and I no longer have division. And I also have the final answer. So this big mess that was up here is really just cotangent minus secant. And we have multiple choice on this. So cotangent minus secant is A. Again, nothing really crazy here. We just had to, in the beginning, sometimes it's good to separate them out into two fractions. Again, try that if you have addition and subtraction in the numerator. Separate them out. Another little trick. All right, question number 7. So question number 7, yeah. This is the last one of 10.1. Question number 7 is the last of 10.1. So we got 1 over 1 plus sine x minus 1 over 1 minus sine x. Okay. So again, they want you to simplify. They don't care if these things are going to be in division or not. Okay. So if you notice, all of the answers to are in terms of sines and cosines. So we want to leave it in terms of sines and cosines. Don't introduce anything like tangent, cotangent, secant, cosecant. We don't want none of that junk. So what are we going to do on this? Exactly the reverse of what we did in 6. In 6, we separated them out. In number 7, put them back together. So notice that the problems that you're doing kind of relate to each other with the one right after them. Okay? So let's put these back together. So that means we need a common denominator. Well, that common denominator is going to be made up of both of these. Okay? So both of these need a 1 plus sine x, 1 minus sine x. 1 plus sine x, 1 minus sine x. Okay? So here's my denominator. Here's what I have. What is this guy missing? It's missing the 1 minus sine x. So we're going to multiply the top and the bottom by 1 minus sine x. So 1 times all of that is just 1 minus sine x. Here's my denominator. Here's what I have. What's missing? The 1 plus sine x. So I'm going to multiply this by 1 plus sine x. And multiply the bottom by 1 plus sine x. And again, 1 times all this is 1 plus sine x. So now all we're going to do is we're going to combine these two fractions together. And I'm also going to FOIL out the denominator, okay? Because there's something there that can help us. So let me show you FOILing out the denominator real quick. So if I take 1 times 1, that's 1. If I take 1 times sine x, that's a positive sine x. If I take sine x times 1, that is a positive sine x. Sorry, this should be a negative right there because that's 1 times a negative sine x. My fault, but that's important that we caught that there. So that should be a minus sine x right there. And then if I take sine x times a negative sine x, I get a negative sine squared x. So what happens right here? These guys cancel out, leaving us with 1 minus sine squared x. That's what the denominator is going to be. In the numerator, you combine like terms. Be careful of this because the minus switches all of these signs. So what we have there is 1 minus sine x. A negative turns that positive 1 into a negative 1, and a negative turns that positive sine x into a negative sine x. So my numerator, 1 minus 1 is 0. Negative sine x is negative 2 sine x. So here's my new denominator. Here's my new numerator. So we have negative 2 sine x all over 1 minus sine squared x. But wait, there's more. Because we've seen this before. Please know that you cannot take a sine and cancel it out with one of these. The reason why you cannot cancel this sine with sine squared is because of the addition and subtraction. This is like one giant family, okay? So you cannot take sine and cancel one of these signs out. It doesn't work like that. But we do know what 1 minus sine squared is, okay? We did that back in problem number 4. 1 minus sine squared is cosine squared. So let's replace this with negative 2 sine x all over cosine squared x. And there's your answer. So we go back, we look. Hey, look, -2 sine x over cosine squared x. There it is. So the answer is A. Okay? So just kind of like I want to hit this one back up again. So we combined our two fractions together. So that means you had to get that common denominator. And then I FOILed the denominator to 1 minus sine squared. And then we combined like terms in the numerator and got -2 sine x. And then from there, we just used a trig identity to change the bottom because we've seen 1 minus sine squared before. It is cosine squared. And that was the answer. All right. Moving on. You did it. We've conquered 10.1. So number 8, this is where we begin 10.2. This is where you learned about the sum and differences of trig values. So what they want you to do right here is they want to know what this answer is exactly. Okay? Your answer will probably have radicals in it. That's why they tell you this information right here. But if you go to your trig chart, which I don't know if your professor will let you have a trig chart on it or not, but if you go to that trig chart and look for 7 pi over 12, you ain't going to find it. I guarantee you, you will not find sine of 7 pi over 12. But we do have sum or difference formulas that can help us out of two trig functions or two angles that we do know that can become this. So one thing I talk to my students about is a lot of chapter 10 is in radians. If you don't like radians, change it to degrees because in the end, we want an exact answer. So changing this and working this in degrees is not going to change anything. Okay. So remember, if you want to change this to degrees, you're going to multiply 7 pi over 12 times 180 over pi. Okay, so this angle in degrees is sine 105 degrees. Okay, so what you need to do is you need to find two angles that can add to 105 degrees, or two angles that can subtract to 105 degrees. There are tons of ways to do this. The easiest one that I'm going to go with is 45 degrees plus 60 degrees. Because I know everything for 45 and I know everything for 60. Another way that you could have done that is 150 minus 45. Okay? Or if you want to keep this in radians, just so you know, pi over 4 plus pi over 3. If I take these two together and add them, I get 7 pi over 12. So now all you have to do is run the sine or the summation of sines formula, which says that if I have sine of A plus B, I get sine of A cosine of B plus cosine of A sine of B. So all you have to do is plug and chug. This is the equation we're going to run. Okay, so we're going to have sine of A is 45 degrees. Cosine of B is 60 degrees. Plus cosine of 45 degrees, sine of 60 degrees. And you should know each one of these values. So sine of 45 is square root of 2 over 2. Cosine of 60 is 1/2 plus cosine of 45, square root of 2 over 2. Sine of 60 is square root of 3 over 2. And so now you just put your algebra skills to the test. So we combine fractions, which you just multiply across the top and across the bottom. Same thing over here. So square root of 2 times 1 is the square root of 2. 2 times 2 is 4. Square root of 3 times square root of 2, or square root of 2 times square root of 3, it doesn't really matter, is the square root of 6. 2 times 2, 4. Since both of these fractions have the common denominator, I don't have to worry about that. And what you will get in the end is 4 in the denominator. And then can these two add each other? Heck no, they're not the same. Remember, you can only add and subtract radicals if they are the same radical. And square root of 2 is not the same as the square root of 6. It's like taking x plus y. They don't go together. They don't like each other. So square root of 2 plus square root of 6. That's what they're looking for. That's the exact answer. You can also have the square root of 6 plus the square root of 2 all over 4. That works just fine too. Okay? And that's it. There's number 8. Number 9Z's. Moving on. So number 9Z's. They're making you work this backwards. Okay? We do know what pi over 4 is, but again, if you know your trig chart, there's no pi over 12. So they want you working backwards. And again, if you don't like working with it in radians, you can turn that into degrees. Okay? So pi over 12 in degrees is 15. So what you're really looking at here of sine pi over 4 cosine pi over 12 plus cosine pi over 4 sine pi over 12 is really just sine 45 degrees cosine 15 degrees plus cosine 45 degrees sine 15 degrees. Because we don't know anything about the 15 degrees, okay, these are two the same. Doesn't matter whether you keep it in radians or you convert into degrees. What they're having you do is they're making you work backwards. And if you look right here, this form matches the form that we have right here. So all they're wanting you to do is take it back to the sine of the two angles being added together. So this really represents sine of 45 plus 15, which is sine of 60 degrees. That's what they really want to know. Oops, can't see it. So it's really sine of 45 plus 15, which is sine of 60. That's what they want to know the answer to. Or if you kept it in radians, this equates out to sine of pi over 4 plus pi over 12, which is really just sine of pi over 3. So again, that's just sine of 60, which in the end is square root of 3 over 2. And there you go. That's what they're after. Okay? I don't think this was multiple choice. Nope. So that's it. That's all they wanted. They wanted you to recognize the sum or difference formula being expanded out here and work it backwards. Okay? So number 10, again, we're just going to take the formula and run it and let it run its course. Okay, we're going to expand this out. So cosine 0 degrees plus alpha. And then this is multiple choice, which is cool, but we'll get to that. So what you need to know in this one is when you run cosine of addition or sum, so cosine of A plus B, that is equal to cosine of A cosine of B minus sine of A sine of B. So that's what they want you to do to this. Expand this out using this information. So cosine of A is 0 degrees. Cosine of B is alpha minus sine of A is 0 degrees. Sine of B is alpha. And so we just figure this information out. So cosine 0 is 1. This is going to stay because we don't know what alpha is. Minus sine of 0 is 0 times sine alpha. So 0 times this is just going to cancel it out. So this all just goes away over here. And what are we left with? 1 times cosine, which is just cosine alpha, which gives us the answer B. Okay. I believe this is the last 10.2. Yeah, this is the last 10.2. They try to get you by kind of making this thing look like a trig function or Pythagorean identity for trig. Cosine squared 90 degrees minus sine squared 90 degrees. Okay? What I want you to think about here is just remember when you're squared, that just means that you have 2 of these. So expand this out. Cosine, oops, not squared, just 90. Cosine squared 90 really just means that I have 2 cosines 90. Cosine 90 times cosine 90. Minus sine squared 90 just means I have 2 sine 90s. Sine 90, sine 90. But wait, we've seen that. Look right here. If you have cosine A, cosine B, sine A, sine B in the subtraction, it really just means that all we were doing was adding those 2 pieces together for cosine. So we're just working backwards, just like what we did in number 9. So just take it backwards. This is really cosine of 90 plus 90, which is equal to cosine 180 degrees. That's all they want to know. And cosine 180 degrees is -1. You could have also worked this out up here with this information because cosine 90 is 0, 0, minus sine 90 is 1, 1. So this all cancels out, leaving you with 1 times 1, which is 1, so -1. Lots of ways to deal with that. It's your call. You know, you could have also worked it out here. Cosine of 90 is 0, 0 squared is 0, minus sine squared of 90 is 1, 1 squared is 1. So 0 minus 1 is -1. Lots of ways around that. Okay. Number 12, we jump into 10.3. Okay, this is when you learn double angle and half angle formulas. So, and here, you're taking 1 minus cosine 34 degrees all over 2. So in this one, a lot like what we did with the summation and difference formulas, their identities, they want you working backwards on this. So who in the double angle or half angle formulas matches this. And when you have 1 minus cosine 34 divided by 2, this matches the sine of the half angle. Because again, they want an exact answer on this. We don't know what cosine 34 is. And if you go to your calculator, it'll kick out a decimal. They don't want that. They want the exact answer. Okay? So the formula for sine half angle actually looks like this. 1 minus cosine A all divided by 2. See how it matches? So really all they want you to do is find out what is sine 34 degrees divided by 2. So 34 divided by 2 is sine of 17 degrees. And that's what they want to know. Okay? They don't actually want you plugging it into your calculator. So this is actually sine 17. Okay? Sine of 17. That's what they're really looking for there. Nothing else. Okay? Because up here, how do I know that? Again, it says write an identity to, or excuse me, use an identity to write the expression as a single trig function. And sine 17 is a single trig function. Okay? So that was the identity that we were using. They just wanted you to take this backwards. Sometimes they do want that exact answer, just not on this one. All right, so this one says, again, write it as a single trig function. So a lot like what we just did a second ago. So they're having you recognize formulas. So 1 minus cosine 62 degrees all over 1 plus cosine 62 degrees. So if we're looking at this, who does this match up with? This matches up with the tangent half angle. Okay? So tangent half angle looks like this. It actually has 3 different forms, but it really is matching up with this form that's right here. 1 minus cosine A, 1 plus cosine A. Okay? And again, it actually has plus or minus in front of it, but that doesn't matter for what we're dealing with. So all we're going to do is just take this backwards. So this guy really looks like tangent 62 divided by 2. And 62 divided by 2 gives us tangent 31 degrees. That's the single trig function for that. Again, just like number 12, they don't want the exact answer. We'll get to that. They just want to know what does it look like as the trig function. So the answer on this one would have been C. Okay, number 14, we are jumping into 10.4. This is where you learned about inverses. So we want to know what is the answer to this? Exact. And it says use pi as needed. So that means we want this answer to be in radians. Okay? So the first thing you need to do when you are checking inverses is we need to know if this is possible. That's the first thing you need to double check. Is this possible? So can we take the inverse with a number like negative square root of 3 over 2? Well, the inverse domain, so the domain of the inverse for cosine is from -1 to 1. So does this number fall within that range? Well, if you just go to your calculator and do the division, this number right here is -0.8660, blah, 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 blah. So is this number within that? Absolutely. So we can take the inverse of this. Okay. Now, when you take the inverse of this, this answer either lies in quadrant 2 or quadrant 1. I said 2 first and then wrote 1. Silly me. So this answer lies in one of those two quadrants. Okay? So we want to know, when is cosine negative square root of 3? All right? So if you know your trig functions well enough, you're going to know that cosine negative square root of 3 over 2, cosine is negative square root of 3 over 2 at 150 degrees or 240 degrees. But again, we are only concerned with quadrant 1 or quadrant 2. Okay? So that means we're going to go with the 150 degrees because this is in quadrant 2. This one is in quadrant 3, so you can ignore that. Junk. Now, again, they want our answer in radians. So just take 150 degrees and multiply it by pi over 180. And you end up with 5 pi over 6. That's the answer they're looking for. The 5 pi over 6. Okay? All right. So you're going to do it again. This time, though, with arctangent. And again, it says in radians. So, and it's multiple choice, so you know that it's all in radians anyway. So right away, you can actually throw out one of those answers. Down here, you can throw out choice B because that's not even in radians. So 15, again, still in 10.4. We want arctangent of negative square roots of 3 over 3. Okay? So in here, so you know, the range, or sorry, the domain for inverse tangent, because we got to know if this is possible or not, is from negative infinity to positive infinity, or in other words, all reals. So that number definitely falls within all reals. Okay? So that means we can take the inverse of this. So you know, for tangent, we are concerned with tangent being in quadrant 1 and quadrant 4. Okay? So we want to know, when is tangent negative square roots of 3? So tangent is negative square roots of 3 at 150 degrees, which is in quadrant 2. So you know right away this answer is junk. And it is also negative square roots of 3 at 330 degrees. Now that's the quadrant 4 answer. Okay? So, problem now is that the way these answers are supposed to be set up, your answers need to be either from negative pi over 2 to a positive pi over 2. So since this is in quadrant 4, the real radian measure of this guy is 11 pi over 6. But if you put 11 pi over 6 up here, it's going to count it wrong because 11 pi over 6 is not within this range of being in quadrant 1 or quadrant 2. It wants the negative version of this number. Okay? Or in other words, you need to go coterminal on this and give me the greatest negative coterminal angle. So in other words, coterminal just means subtract 360. Or in this case, in radians, subtract 2 pi. And if you go and subtract this information, you get negative 30 degrees. Or in other words, a negative pi over 6. And that's the answer they're looking for, the negative pi over 6. So if we come back to this, we want C as our answer. Notice they put that 5 pi over 6 right here. Well, actually, that one doesn't even make any sense because that's not even one we talked about. But my gut feeling says that I think they'll put in an 11 pi over 6. Actually, the 5 pi over 6 represented the 150. So here's the 150, but you can't use that because it needs to be in quadrant 1 or quadrant 4. So it's actually C is our answer for this. All right, 16, moving on. Guys are killing this. I don't even know why you need me. All right, again, if you're looking at these things, these are all 10-4. We're just taking inverses, okay? Still 10-4. Right here is where we're going to hit 10-5 at number 20. All right, so 16, inverse. So cotangent, -1. We got negative square root of 3. All right, so the domain of the inverse of cotangent is just like tangent, -infinity to infinity. So again, this guy is all reals. And its domain, or it falls within quadrant 1 and quadrant 2. Okay? So we want to look up our answers for this. When is cotangent negative square root of 3? Well, cotangent is a negative square root of 3 at 150 degrees, which is quadrant 2, or 330 degrees, which is quadrant 4. So which one do we want for our answer? Yeah, the 150. And the answer in radians for that, we already talked about, 5 pi over 6. So there you go. Okay. The ones that you got to be careful of is usually when they ask for the quadrant 4 answer, it's got to be the negative version of that angle. Okay. So if you're ever dealing with quadrant 4 answers, get the negative version of the angle. Do not keep it the positive version, like the 11 pi over 6. They don't want that. They want the negative version. Everything else you can just keep the way it is. All right. Moving on. Moving on. All right, number 17. So this time we got y equals secant -1 of the square root of 2. So again, domain of secant inverse is from from negative infinity to -1. Give me a second to fix this. So it is from negative infinity to, oh, you can't even see it either. Let's switch it over. Negative infinity to -1, bracket, union with 1 to infinity. Okay? So the question is the square root of 2 in any of these intervals? And if you take the square root of 2, this guy is 1.4142, blah, 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 blah. So that definitely falls within this interval. So we can definitely take the inverse of this. Okay? So the inverse of this, these lie in quadrant 1 or 2. Okay? So where is secant? The square root of 2. So secant is the square root of 2 at 45 degrees or at 135 degrees. Sorry, not 135 degrees. Or 315 degrees. Okay? 45 is in quadrant 1. This guy is in quadrant 4. But again, we don't want the quadrant 4 answer. So the answer to this guy is 45 degrees, which is pi over 4 in radians. Okay? All right, moving on. You guys are doing great, asking lots of questions. Just kidding. You're not even here. We miss you, though. All right, so number 18, they want to know what is cosecant -1 at 3.04. Now, this one, they express, please, using the calculator. Okay? So make sure that we use the calculator on this. Now, if you go to your calculator, and I'm going to show you, there's no cosecant -1 on here. All we have is the inverse of sine, the inverse of cosine, the inverse of tangent. Oh, actually, even before we go to the calculator, the domain of cosecant inverse is the same as the secant. So negative infinity to -1 union 1 or bracket 1 to infinity. So obviously that number fits in our domain. This number is right up in here, so we're good to go. You're going to look for quadrant 1 or quadrant 4. Okay? But again, that doesn't really matter to us in this because we're going to use the calculator and it will shoot us out the answer in quadrant 1 or quadrant 4. Okay? So in here, let's look. It wants this in degrees. So the first thing before I even figure this out, I'm in radians. I need to fix that. So change this mode into degrees. And now I'm ready to go. Well, how is this problem going to work? Well, what you need to remember, because our calculator doesn't have cosecant inverse, that means we need to turn cosecant into sine, cosine, or tangent. Okay? So let's talk about what you really see here. In this problem, what you are being told here is we're being told that cosecant of some angle is equal to 3.04. Okay? Because in order to find this angle, I take the inverse of both sides. But we don't have cosecant on our calculator, as I keep saying. So change this into what we know it to be, or what we know about cosecant. Okay? We know that cosecant is equal to 1 over sine. Okay? Or another way to think about it is sine is equal to 1 over cosecant. And I keep writing cosine. Sorry about that. So again, this is cosecant. And down here, this is cosecant as well. All right, trying to write over my white out. So we can use these identities to change things around here. So I can change this, okay, using this information. So this is really sine of some angle equal to 1 over cosecant. Well, what was cosecant? 3.04. So sine is equal to the reciprocal of this. So just put 1 over that number. And this we can definitely solve. We can definitely go into our calculator and figure out what our angle is, which will be the same as this one, using sine inverse of 1 over 3.04. Because these two represent the same angle. So this is what I'm going to put in my calculator to get my answer. And it will either be in quadrant 1 or quadrant 4 as the final answer. So we go to our calculator. And so I hit second sine, then alpha y equals 1 over 3.04. And there's our answer. So it is in quadrant 1. And it's 19 point, let's see here, what did they tell us to round to? That's not it. Round to 2 decimal places. So 19.20 degrees. And that's our answer. Okay. All right. Number 19, the last one in 10.4. So number 19, they just want you running this information. So cosine of the cosine inverse of 2 square roots of 2. Okay? So you're just running the problem as it is. Work with your parentheses and then work on the outside piece. Square root of 2 over 2. And they want this to be an exact answer. Okay? So obviously this is not going to end in degrees or radians. This is going to end maybe with a radical and things like that. All right, so the first things first, they want to know, what is this inverse? Well, the question is, can we do that inverse? So the domain of the inverse cosine is from -1 to 1. So the question is the square root of 2 over 2 in this domain? Well, if you take the square root of 2 and divide that by 2, this number is 0.7071, blah, 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 blah. So that number is definitely in here. So if we take the inverse of that, we are going to be dealing with quadrant 1 or quadrant 2. So where is cosine inverse, or in other words, cosine square root of 2 over 2? And it is square root of 2 over 2 at 45 degrees, which is in quadrant 1, which is the one that we want. Or cosine is the square root of 2 over 2 at 315 degrees, which is quadrant 4. So yeah, definitely throw that guy out there. So we now know that this right here is really just 45 degrees. So we have now worked out the inside. And then now all they want to do is they want to know, well, what is cosine 45 degrees? Well, that's easy. We know that to be the square root of 2 over 2. And there it is. There's your answer. So number 19, yeah, fill in the blank. You put square root of 2 over 2. So again, you start by working inside the parentheses, and then you work to the outside. Okay? All right, number 20, magic number 20. We are now solving in 21 through 25. This is all about solving, okay? So right now we are in 10.5. So we got 3 tangent x plus 2 equals -1. It also tells us we're on the interval of 0 to 2 pi. So that means our answers need to be in radians, okay? So let's find our answers. So when solving, the basic idea is just get the trig function by itself so we can take inverses. That's why we learned about inverses in 10.4, so we can apply that to solving. So we want to get tangent x by itself. Well, how do I get rid of a plus 2? Subtract 2. So 3 tangent x equals -3. Divide by 3, divide by 3. Tangent x equals -1. Okay? So how do I get the x by itself? Or in other words, how do I figure out the angle? You take the inverse. Your last step should always be about taking a trig inverse. So we want to figure out what this answer is. What is tangent inverse of -1? And so again, applying what we know, again, the big thing is, can we do this? And if you haven't noticed, when you guys did everything in 10.1, from question 14 all the way through question 19, you pretty much talked about the inverse of every trig function possible. So you already know that the domain of the inverse of tangent is all reals. So this number can happen. So we just want to know, when is tangent -1? And we don't have to worry about the range on this one because we want to be in the range. Our interval is expanded. We want to be within this interval. And so this is going to have the 2 answers. We're not going to throw any answers out on this guy because they will fall within this interval. So when is tangent -1? And tangent -1 is at 135 degrees and 315 degrees. 315 degrees. But again, because our interval is in radians, 315 degrees is 7 pi over 4. 135 degrees is 3 pi over 4. And those are the answers we want. Okay? All right. But of course, there's the degrees for them as well, too. There's nothing wrong with knowing the degrees. All right, number 21. So number 21, still on that same section. Sine x secant x equals 2 sine x. All right. So in this one, and again, it's not telling us what interval we're in, but it does say use pi down here as needed. So we're going to be in that same interval from 0 to 2 pi. Okay. So when you read that fine print down here, if you see the pi, that means you're in radians. Okay. So first things first with these, you need to get all of your trig functions over on one side. Okay. That's a good thing. Get all your trig functions over onto one side. And is that sine squared? Nope. Just sine. So we're going to subtract 2 sine x to both sides. Okay? So when you subtract that over, just so you know, these two do not get together because they're not the same. This is like xy minus 2x. Xy does not get together with just a regular x, okay? So what we have over here is sine x, secant x, minus 2 sine x equal to 0. The reason why I did this, because generally when you have two or more trig functions, you probably have some factoring that's going to happen. Especially if it says something squared up here, you definitely probably have factoring going on. But if I look at this, remember how I kind of related that just a second ago. Sine is like x, secant is like y. This is what you're looking at. So what do both of these have in common? They both have an x. That's a GCF. Pull it out. And that leads you to something that you can solve. Trig functions act the same way. Both of these have sine. Pull that out, which will leave you with secant minus 2 equal to 0. See, these trig functions kind of act like variables. Same way algebra variables act, the trig functions have to act. Okay? All right, so now, since everything is factored, how do we solve by factoring? Well, once everything is factored, all you do is you take each piece and you set it equal to 0. That's that, oh gosh, name's eluding me right now. Give me a second, I'll think of it. This is zero product rule. Woo, almost forgot that. Can't believe I did that. So we just take each part, the GCF gets set equal to 0, and the parenthesis gets set equal to 0. So all we got to do here to solve is we're going to take inverse sine of both sides. So what we want to know is, when is sine 0? Okay? And again, you already know what the domain of sine is. It's from -1 to +1 in brackets. So this is definitely in there, so we can do this. And sine answers fall in quadrant 1 and quadrant 4. Okay, but that doesn't really matter. Okay, so when is sine 0? And sine is 0 at 0 degrees, or sine is also 0 at 180 degrees. Okay, you could say 2 pi here or 360, but because our interval has a parenthesis at that, we wouldn't include that. So in other words, in radians, this is 0 or pi. Okay, so there's two of our answers right now, 0 and pi. All right. So to get the other answers, we now look to the second equation to solve. So we want to solve this guy, and I should have probably moved that over more. Let's do that. Secant x minus 2 equal to 0. This is why you shouldn't use pen when doing math. As you can see now, I'm painting on my page to cover up my mistakes. So add 2, add 2. Secant x is equal to 2, and take the inverse of both sides. So secant inverse secant inverse. Okay? So in here we now know that we need the inverse of 2. Or in other words, we want to know, when is secant 2? And again, 2 is in the domain because we've seen the domain is from -infinity to -1, union with 1 to +infinity. So this is in that 1 to +infinity. The answers for secant, we know that they lie in quadrant 1 and quadrant 2, but again, that doesn't really matter because we're on an interval of 0 to 2 pi. So when is secant a +2? Well, secant is a +2 at 60 degrees, or secant is also a +2 at 300 degrees. Okay, so 60 degrees is really pi over 3 in radians. And 300 degrees is really 5 pi over 3. So in the end, our final answers are the 0, the pi over 3, and the 5 pi over 3. But again, there's nothing wrong with knowing the degrees as well, because sometimes we ask for the degrees. Okay, so that's why I like to provide both. And there's number 21. You had 4 answers. Nothing wrong with that. All right, number 22. So here you can see the interval has changed on us. We're going to be from 0 degrees to 360 degrees. So we have 8 cosine squared theta sine theta minus 4 cosine squared theta equal to 0. Hopefully you notice something. This is a lot like what we just did in number 21. Both of these have common elements. There's GCFs here. First off, 8 and 4, the GCF between those is 4. Both of these also share cosine squared. So pull out cosine squared theta. So this is the GCF we're going to take out of everybody. Well, 8 divided by 4 is 2. And then that's sine theta minus 4 divided by 4 is 1. Cosine squared got pulled out. And there's what we're solving. Okay? So we're going to take, and just like before, we took each one of these pieces and set them equal to 0. It's the same thing we're going to do here. 4 cosine squared theta equal to 0. And 2 sine theta minus 1 equal to 0. So divide by 4. And that gives you cosine squared theta equal to 0. And then how do you get rid of something squared? You take a square root. Remember, when you take a square root of both sides, you really have plus or minus here. But because this is 0, you don't really have plus or minus of 0. But if this was a number, you would need that plus or minus there. That would be super important. So how do I get theta by itself? Cosine inverse, or arc cosine. So we're looking for, when is cosine 0? Okay? And this is a lot like when sine was 0 with the domain. The domain's from -1 to +1 inclusively. And so when is cosine 0? Well, cosine is 0 at 90 degrees, which in radians is pi over 2. Even though we don't need radians, I still like to give it to you. And cosine is also 0 at 270 degrees, which is 3 pi over 2. So there are 2 of our answers so far. And again, I gave you the radians for it. Nothing wrong with that. All right, so over here we're going to solve. So we're going to add 1. 2 sine theta is equal to 1. Divide by 2, divide by 2. Sine theta equals 1/2. So take arc sine, and we get to know, when is sine 1/2? And again, this is in the domain. So when is sine 1/2? And that happens at 30 degrees, which is pi over 6. It also happens at 150 degrees. Kind of running out of room, but I'll get it in there, which is 5 pi over 6. And there you go. There are the degrees. 30 degrees, 150 degrees. And again, down below, there's the radian answer as well. So 90 degrees, 270 degrees, 30 degrees, 150 degrees. There's your answer. So again, we're not doing anything crazy here when it comes to the solving. It's all straightforward, I promise you. So that was number 22, almost done. Number 23, we are still in 10.5. So 2 sine x minus the square root of 2 equal to 0. And so again, in here, it's multiple choice, but this time they're asking for all exact solutions. So we'll talk about that after we go through and solve. Okay? So the first thing you want to know is that looking at our answers are in radians. So that means, first off, we're working from 0 to 2 pi. Let's get all those answers, and then we can talk about what it means to be exact. All exact answers. So again, easy thing is, it's already set up, ready to go. Just get sine by itself. This is just like what we did in number 20. But it's sine this time and not tangent, because I think number 20 had tangent in it, if I remember right. So 2 sine x is equal to 0 plus the square root of 2 is the square root of 2. Divide by 2, divide by 2. So to get x by itself, we're going to take the arc sine of both sides. So sine -1, sine -1. So we want to know, when is sine square root of 2 over 2? And again, this is in the domain, so it's all good. Sine is the square root of 2 over 2 at pi over 4, which is really 45 degrees. And or 135 degrees, which is 3 pi over 4. Okay? So this is if we stayed in here, but we want all answers that are possible. So remember to think coterminal on this. Anytime I'm at an angle that relates back to 45 degrees, it's the same answer. So if I add 360 to this, the angle 405 degrees, 405, is the same answer. If I add another 360 to that, 765 degrees is the same answer. And the same thing if I went backwards, 45 minus 360 degrees, negative 315 degrees is the same answer. So what they're after is they want an equation, or actually an expression, that represents all those different angles. And the idea is just think coterminal. So all we want to do is take 4 pi and add 2n pi to it. So they separate these because they like to put pi at the end, where n represents an integer, like +1, +2, +3, or -1, -2, -3. And what those integers tell you is how many times you're going around the circle, because 2 pi is a full circle, like 360 degrees. So if I put 1 in here, that means go around the circle 1 time, which means that would put this guy at the 405 degrees. If I put in a -1, that means go backwards around the circle, so clockwise, which would put this angle at the negative 315. So the integer you plug in here is just how many times you want to go around the circle. So right here, this is one of our answers. The other guy looks the same thing, or looks the same way, I should say. So 3 pi over 4 plus 2n pi. So there's our answers. This gives me every possible angle that will work in this. Okay? So first, work within 0 to 360 degrees. Get those answers, and then basically all you do is you add 2n pi onto it. Okay? So if we go back, I believe this was multiple choice. So right here, choice B is our answer, because it's got the 2 in pi. Okay. 24. This jumps us into 10.6. 24 and number 25 are both 10.6. Okay. Excuse me. So on this one right here, sine half angle equal to negative cosine half angle. All right. So again, it wants the exact answers. So we don't have to worry about all the answers. That's going to come in number 25. Okay. Excuse me. So in this one has a little trick at the beginning. And the trick in this one is to understand that if I square both sides, okay, if I square both sides, the answers are still the same, okay? And the reason why I want to square both sides is because we have a relationship that says sine squared x plus cosine squared x is equal to 1. It's going to allow me to change one of these into the other function. Okay? So the first thing is, please understand that if I square both sides, they're both going to be the same answer. And just so you know, when you square a negative, it becomes positive. Now, I can either take this and solve it for cosine, or I can solve it for sine. It doesn't matter. I'm going to go ahead and solve for sine. So we're going to subtract cosine squared x minus cosine squared x. So sine squared x is equal to 1 minus cosine squared x. Now I have something I can replace this with. So I'm going to take this 1 minus cosine squared and replace this. And even though this is x, it's the same thing if I put x over 2. Okay? So 1 minus cosine squared x over 2 is equal to cosine squared x over 2. Okay? Well, let's get all the cosines onto one side. So it's easiest to take this guy and bring it over here. Okay? But if you brought this over here, you're going to get the same answer. It doesn't matter. So I'm going to add cosine squared half angle to the other side. Okay? So what we have is these two can get together and become 2 cosine squared half angles equal to 1. Well, how do I get rid of the 2 in front of this? Divide by 2, divide by 2. So what we are now looking at is cosine squared half angle equal to 1/2. How do I get rid of something squared? Square root it, which means that you will be square rooting the top and the bottom, which means that you will have to rationalize this, which to rationalize is to multiply by a square root of 2, square root of 2. And what we find out is that cosine x over 2 is equal to, I just talked about this a couple minutes ago, when I square root both sides, there should be a plus or minus in front of this. And the simplified rationalized version of this, well, the square root of 1 is just 1. 1 times the square root of 2 is the square root of 2. And when you multiply by the same radicals on the bottom, the radical disappears. So this is what we're looking at. Cosine of a half angle is equal to plus or minus square root of 2 over 2. How do I get the half angle by itself? Inverse. So just like before, okay? Now, here's the thing. We took this inverse here, but you are technically inversing 2 values, okay? So what we are looking at for number 24 is cosine inverse of a positive square root of 2 over 2. We want to know what that is. And we are also looking at cosine inverse of a negative square root of 2 over 2. So let's find these answers, okay? So the positive square root of 2 over 2 gives us an answer of 45 degrees, which is pi over 4, or square root of 2 over 2, positive 315 degrees, or 7 pi over 4. Cosine negative square roots of 2 over 2 gives us 135 degrees, which is 3 pi over 4. Or it gives us 225 degrees. Or in other words, 5 pi over 4. I don't know why I put that line there. So that is what the inverse of cosine is equal to. Here's one little piece you have to be careful of. That's what this would equal if we were just x here. But what we have here is x over 2. So all these little problems, all these answers are set equal to x over 2. Our job is not done. We have an extra step here. So again, they want our answer in radians. So we're taking all of our answers and we're setting them equal to x over 2. And I ran out of room. I don't budget for space very well sometimes. Okay. Also, the other thing in this one, it says that we are stuck in the interval of 0 to 2 pi, just like what we experienced in all the 10.5s. Okay, that's important to us now. So when we look at this, how do I get x by itself? In all of these, you're going to multiply both sides by 2. And that will tell us our final answers, which we will then do some stuff to. Multiply by 2, multiply by 2. That looks like a power of 2. Let's move these down some. Sorry about all my messes. Again, this is why we don't write in pen. But I do this because I'm making a answer key. So I want it solidified. All right. So again, we're multiplying both sides by 2. Okay, a little bit better. So here we get x equal to pi halves. Here we get x equal to 7 pi halves. Here x is equal to 3 pi halves. And here x is equal to 5 pi halves. Now here's the issue. Again, our range is 0 to 2 pi. 2 of these answers don't belong. This guy goes away because 7 pi over 2 is outside this interval. And this one goes away because 5 pi over 2 is outside this interval. So you're left with these two answers. But in this problem, I encourage you to check answers. Okay? Check your final answers. So what we're going to do is we're going to take these and we're going to plug them back into our original equation, which was sine x over 2 equal to negative cosine x over 2. So if I plug back into the first one, it'll be sine of pi over 2 divided by 2 equal to negative cosine pi over 2 divided by 2. So this becomes sine of pi over 4 equal to negative cosine of pi over 4. So sine of pi over 4 is the square root of 2 over 2. Cosine of pi over 4 is negative square root of 2 over 2. Does this make sense? No. So we now throw out pi over 2. This answer is now gone. We check the other guy. Sine of 3 pi over 2 divided by 2 equal to negative cosine 3 pi over 2 divided by 2. So this gives us sine of 3 pi over 4 equal to negative cosine of 3 pi over 4. So sine of 3 pi over 4 is square root of 2 over 2 equal to negative cosine of 3 pi over 4 is a negative square root of 2 over 2. What happens with two negatives by each other? They turn positive. Does this make sense? Absolutely. So there's only one answer to this. X is equal to 3 pi over 2. That's what they want. Or in other words, 3 pi over 2, we know what that is. That answer is 270 degrees. That's number 24. I think that's your hardest problem that you have on this exam is number 24. Just be careful. Check those answers. Make sure that you are also in the interval. Those are the two important things to watch out for in number 24. And I believe you should have had something like that in your assignment as well for 10.6. So number 25, the last 10.6 problem. Here we go. This is it. You've made it to the end. So this one wants all exact solutions. So again, we'll talk about that as soon as we're done solving. Okay? So here's our problem, and everything's in radians. So again, I'm going to work this thinking we're from 0 to 2 pi. Okay? So let's get this by itself. So we're going to divide by 6, divide by 6. Sine x over 2 is equal to 1/2. How do I get the x over 2 by itself? Inverse sine. So we want to know, when is sine 1/2? And so sine is 1/2 at pi over 6, which is 30 degrees, or at 5 pi over 6, which is 150 degrees. But again, just like last time, that's if this was x. These guys are not equal to x. Both of these answers are equal to x over 2. Which gives us 5 pi over 6. Okay? So we're going to go ahead and multiply both sides by 2. Multiply by 2. And what we get here is pi over 3. And here you get 5 pi over 3. Okay? And both of these answers are still within that interval. Okay? Now, remember how before we would say this would be plus 2 pi n for all these answers. But that's when it was a regular x. Okay? So up here, these would have had the plus 2 pi n. But what did we have to do in the end? We had to multiply by 2. So that also changes this information. So if these would have been plus 2 pi n, when it comes down here, we also have to multiply the plus 2 pi n by 2. Okay? So our final answer down here is pi over 3 plus 4n pi. This guy is 5 pi over 3 plus 4n pi. Those will represent all of our answers. And again, n is an integer still. So if we come back out here, look at that, 4 pi n or 4n pi. Which one is it? It's right here at C. And that right there represents your guys's exam 2. So you saw that in the verifying, we're looking for some simple, straightforward things using either trig identities, like Pythagorean identities, or just knowing that tangent is equal to sine over cosine, or sine or cotangent is equal to cosine over sine. And then that one problem just to be on the lookout for is your number 24. Just be careful of it. Okay? But everything else, you got this. Thanks for stopping by, and you stay classy, trig students.